MakerSnack.
Setting up a Fibonacci micro to work with CircuitPython. Hello friends, it's Prof G, and I've been wanting to experiment with the Fibonacci 64 micro board for some time and finally got around to setting one up. Now the Fibonacci 64 micro is one of several beautiful LED boards by Evil Genius Labs run by Jason Kuhn. Be sure to follow Jason and his company for lots of inspiration and info on cool projects. Jason isn't sponsoring me or anything, I just think he's awesome. And if you buy something from his company, you get this ultra cool Evil Genius Labs sticker too. Now the Fibonacci 64 micro is a 40mm circular disc. That's just under 1.6 inches for my fellow Americans. It has 64 individually addressable RGB LEDs surface mounted in a Fibonacci distribution. It's specifically designed to be soldered directly to any microcontroller with the Adafruit QT Py/Shao seed form factor. That's these super tiny boards that are so small they'd fit inside of a US quarter. Now the Fibonacci 64 micro also has 4 capacitive touch pads, although a word of warning, if you're using a QT Py RP2040 like I first used, this board doesn't have built-in capacitive touch like the other QT Py boards. You have to add an external resistor to get cap touch working on this board. I found this out the hard way and abused my Fibonacci to the point of damage, a problem I could have avoided had I paid closer attention to the QT Py RP2040 documentation. And do know that's not a problem with the Fibonacci, the board is very sturdy, it was entirely my fault. Also, at the time of this writing, the QT Py RP2040 doesn't support Arduino, so if you want to use Arduino or CapTouch, avoid the otherwise great QT Py RP2040 board. Anyway, you can code up all sorts of animations in Arduino or CircuitPython, and Jason has some cool Arduino sample code on GitHub. Also, be sure to check out the Evil Genius Labs documentation. They very well might have CircuitPython animations up here by the time you're watching this video. But I wanted to use CircuitPython, so here's what I did to get started. So back to my very simple quick demo. First, I soldered up my QT Py. This technique should be the same for any board with a QT Py form factor. There are 3 pads that you need to solder to get the lights working: M0, ground, and 5 volt. Before soldering, I tinned these pads, then taped the QT Py to the Fibonacci to hold it steady, and then I soldered the 3 main pads, plus a few other pads to make sure the connection between the board and the Fibonacci was nice and secure. As you can see, I continue to be genuinely terrible at soldering. Now, Evil Genius Labs has some additional information on the site regarding setup for those that might be completely new to this. Then I installed CircuitPython on the QT Py. And if you're new to setting up CircuitPython on a board, I've got a tutorial in CircuitPython School on my channel. But briefly, after I soldered things up, I held down the boot button on the board, and while holding that button down, I plugged the board into the USB cable connected to my Mac, and I continued to hold down the button until the RPI-RP2 volume showed up on my desktop. Sometimes booting a QT Py can be a little bit tricky. If you need any tips, be sure to see Adafruit's documentation. Then I went to CircuitPython.org. I downloaded the latest version of the UF2 CircuitPython file for this board. In this video, I'm using version 7.1. I dragged the UF2 file that I downloaded onto my board. It dismounted and remounted. The mounted controller was then named CircuitPython. At CircuitPython.org, I also downloaded the latest library bundle for CircuitPython, and then I went into the lib folder in that bundle, and I found any related libraries I thought I might use. Neopixel.mpy is a must. You also might want to add Adafruit LED animation and Adafruit Fancy LED if you want to experiment with more animations. And I dragged these items into the empty lib folder in the CircuitPy volume. Then to get things running, I wrote this small script. You can find it in this GitHub repo. That's github.com/Gallagher/fib64, all lowercase. The simple rainbow spiral demo is the code that I'm about to walk through. I'm just going to highlight and copy this code, paste it into the Mu editor, which you can download from codewith.mu, and I'll save this to my CircuitPy volume as code.py. And you can save over any existing code that might be on the board. And here's how it works. I imported all modules that I needed, board, time, NeoPixel, and color wheel, which is in the Rainbow IO library. And then I set up the NeoPixel object representing the 64 LEDs, and I named this object LEDs. Now for QT Py boards, the M0 pin, that's the control pin for the LEDs that's soldered to the Fibonacci board, is referred to as board.MOSI, in all capital letters, M-O-S-I. I also set brightness to 20%, which is plenty bright for the Fibonacci. I set auto write to false, which means that I need to call the write method on the LEDs object anytime I want to activate any of the light changes I make in the code. Then I turn off the lights in case any were lingering on from a previous execution. I go through the range of LEDs from 0 to 63. That'll get me through all 64 lights. I light up each LED in a number from the color wheel. In an earlier tutorial in CircuitPython School, I pointed out that the color wheel function returns a usable NeoPixel color on any input from 0 to 255, and that'll move you through a rainbow of colors. Now, since I only have 64 lights, not 256, I multiplied the LED number by 4 to evenly distribute 64 colors in a pattern that starts at red and ends in red. Then I wait 1/100th of a second after lighting up each light, and when I'm done, I turn down the brightness from its current brightness value. Brightness for neopixels is a value from 0 to 1.0, but I need to run through a range of integers, so I multiplied the brightness by 100 and then counted down by ones, one at a time. I waited 1/100th of a second, divided the LED brightness value that I'm getting in my arrange by 100, that's to convert it to a number from 0.0 to 1.0, wrote the changes to the brightness, and continued through the loop. Then when I've gone through the entire range, I turn off all of the lights by filling my LEDs in with 000 for RGB values, and I start over. And that's it. No, I'm not especially skilled at creating LED animations, but feel free to visit the GitHub repo that's in the description, and I'll add new code here as I try out any new animations. Just make sure that you rename any of the Python code files ending in py as code.py when you save them to your device. Now, I've got another file in this repo that will cycle through most of the animations in the Adafruit_LED_animations library. Unfortunately, I destroyed my board before getting a good video of this in action. That's why you see some of the lights aren't animating properly, but give it a try for more LED goodness. And another thing I want to try out is this hack from Deborah Ansel of Geek Mom Projects, or as I refer to her, the notorious GMP. She rigged up a battery so that you could wear a small Fibonacci board as a necklace. Definitely check out Geek Mom Projects on Twitter and regularly visit her blog. She's just awesome. Got any of your own animation code that you want to share? Add it in a link in the comments. And remember, if you subscribe, I post videos regularly, including all of the videos that I create for my university flipped class physical computing course and my iOS development course. Now go make something awesome.